Welcome to this session. In this session, we will discuss about critical path method. To solve the critical path method, first we want to calculate all the event times. Early start, this is the time at which an activity can start after completing all its preceding activities. Similarly, late finish is the time in which activity can be completed without delaying the entire project. Early finish, it can be calculated using the formula early start plus duration, and late start can be calculated using the formula late finish minus duration. After to that event timing calculations, we want to follow forward pass in that all early finish can be calculated. This happens when the network is drawn and we are proceeding forward through the network considering all the predecessor activities. So in this forward pass, we want to follow a rule, that is, we should take the maximum value from different parts of the network. Example, if a project start is accounted as day 1, then the formula to calculate the early finish time will be early start time plus activity duration minus 1. If a project start is accounted as day 0, then the formula is given as early finish is equal to early start plus activity duration. Similarly, backward pass, in this pass, late start can be calculated. So this happens in a network moving from the backward. So in this process, we want to take the minimum value from different path of the activities. Example, if a project started as day 1, then late start can be calculated using the formula late finish minus activity duration plus 1. And if project start is accounted as day 0, then formula will be late start is equal to late finish minus activity duration. We will solve the problem. For the given activities, there is a predecessor relationship. Using the predecessor relationship, we want to draw the network and we want to calculate the critical path using AOA and AON network. The step-by-step procedure will be, first, the network should be drawn, then all the event times should be calculated using forward pass and backward pass, then drawing the event timings table, then identifying the critical path, then total project duration. So drawing of network. So this is the question. If we take activity A, there is no predecessor, so we can draw like this. Then activity B, the condition is after completing activity A, B should start. Then for activity C, B should be completed. Then for activity D, again B should be completed. For activity F, both C and E should be completed. So here E is called dummy activity. So it is mentioned as a dotted arrow. Next, G should be completed after D, and similarly H can start after F, and finally I can start after completing G and H. So like this, the network can be drawn using AOA network. And these are all the durations we want to fill below the arrow. So this representation is said to be activity on arrow. So in this activity on arrow method, the forward pass will be applicable for calculating all the early finish times. And similarly, the backward pass will be applicable for calculating all the late start. This is an example how early start and early finish can be calculated for all the activities. So in this network, the representation will be as shown in this figure. So early start and late start will be represented in the tail of the activity, and early finish and late finish will be represented at the head of the activity. So here head refers the arrow, tail refers the end of the arrow. And using the forward pass, we can calculate all the yearly finish times. So when we progress from the activity A, so 0 plus duration is 14. So 0 plus 14, that early finish of the activity A will be 14. Similarly, at B, 14 plus 7, 21. Then at C, 21 plus 14, it is 35. But from D, we will be getting the maximum value. So the main rule is through forward pass from different arrows, if we get maximum value, that we want to take it further. So likewise, for activity F, 42 plus 7, 49, and for G, 42 plus 14, 56, and for I, it is 49 plus 7, 56, and 56 plus 1, 57. So like this, we want to fill the network. So these are all the step-by-step calculations given for backward pass. So similarly, from the backward pass, we can calculate all the late start values. From node 8 to 1, we want to proceed from the backwards. Example, at node 8, the final duration is 57. We want to fill the same what we are getting from early finish. And using the formula 57 minus 1 at node 7, it is 56. Similarly, at the node 6, 56 minus 7, it is duration, so 49. So likewise, we want to fill all the late start values. Then the critical path can be identified by the difference of any two start time or finish time. If we get the value 0, then the activity is said to be critical activity. The path connecting all the critical activities are said to be critical path. So in this network, the critical path is activity A to B to D to G to I. This is the path. We can call it as critical path. Then the total project duration will be adding all the durations in the critical path. It means that adding the duration of all the critical activities, we will get the total project duration. Next, we will see how to calculate the float. So it is a sample calculation given here. For this particular sum, the float value is not widely spreaded. So this is for example, you can take the formulas and calculation steps. So this is the network we carried out from the previous slide, and the total float can be calculated from the formula, the difference of late start minus early start, or late finish minus early finish. After that, there are other three types of floats: free float, independent float, inference float. So what is what is free float and what is independent float? We can see one by one. Free float can be calculated using the formula total float minus head slack. Independent float can be calculated using the formula total float minus tail event slack. So head event slack can be calculated using the formula late finish minus early finish of that activity. Similarly, tail event slack can be calculated using the formula late start minus early start. For example, if we take activity A, the head event slack can be calculated at node 2, that is from the arrowhead. So late finish is 14 and the early finish is also 14. So 14 minus 14, you will get 0. Similarly, we want to calculate all the head event slack. After calculating the head event slack, the free float can be calculated using the formula total float minus head event slack. Similarly, the independent float can be calculated using the formula total float minus tail event slack. For activity A, the tail events lag will be at the end of the arrow, that is 0 minus 0. Similarly, you can calculate all the float values. So this is the example of AOA representing all the event timings as well as tail event, head event, lag representations. This is the example already we discussed in the previous slide. Then for the same problem, if we draw using AON network, then the difference will be you no need to draw the dummy activity as we have seen in the previous example. So the AON network is very easy when compared to the DUF activity on arrow network. For the same problem, the activity on node network can be drawn like this, and the representation will be mentioned in the node itself. It means that the activity will be represented inside the node and duration will be given below the activity A, and the representation at every node will have all the event timings. So in this network, the free float or the total float can be easily identified. Thank you.